Hi, my name is DEG30013. I'm from class DE 5B.
Hello sir, my name is Hydroelectric. I'm coming from DE 5B. So today I'm gonna explain about EOC chapter 4. And first two question I will able to answer the two question, and last third question will be explained by my teammate Ratneswaran. So let's go to the first slide. For my first question, I'm gonna explain about the hydroelectric installation and the turbine example for each installation. So first installation is low head installation. Low head hydropower plant are those with 1 megawatt or less capacity and are designed for change in the water level of no more than 30 meters. Those used can produce hydraulic head without the aid of dam or water storage facility. Utilizes the energy produced by the tidal movement that naturally occurred along the river, has little negative environmental impact on the environment. For the first installations example is Kapalan turbine, a type of propeller turbine that is commonly used in low head installation due to its high efficiency and versatility. A suitable turbine runner for this type of installation will be a Kapalan runner. So next is medium head installation. Medium head installation typically have a head of water between 30 and 30 meters. Those installations are commonly found in mountains regions and are used for power generation and irrigation. The turbine used in the medium head installation are generally of the Francis turbine, a type of turbine that is commonly used in medium head installation due to its high efficiency and flexibility. A suitable turbine runner for this type of installation will be a Francis installation. Lastly, high head installation typically have a head of water more than 300 meter, same as medium head installation. So the turbine used in high head installation are generally of the Pelton or Francis type turbine. So now I'm going to explain about the Pelton turbine, a type of turbine that commonly used in high head installation due to its ability to handle high head of water. The suitable turbine runner for this type of installation will be a Pelton runner. Okay, coming to my next question, I'm going to discuss about the two potential of hydroelectric power plant in generating grid scale electricity supply and two environmental impact of hydroelectric development by referring to a real power plant example that have been previously reported in Malaysia. Hydroelectric power plant are reliable and renewable source of energy that can provide a significant portion of the electricity supply of a region. Malaysia has few hydroelectric power plants, including the Bakun hydroelectric power plant at Sarawak, which is the largest in the country. Here, two potential benefits and two environmental impact of hydroelectric power plant using the Bakun hydroelectric power plant as an example. There are two potential of hydroelectric power plant in generating grid scale electricity supply. Reliable and consistent power generation. The hydroelectric power plant can generate a steady supply of electricity, which is important for maintaining a stable and reliable grid. Unlike wind and solar power, which are depend on weather conditions, hydroelectric power can be generated consistently through the year, regardless of weather condition. Next, Low operating cost. Hydroelectric power plant has a relatively low operating cost once that are built. The main costs associated with the hydroelectric power are the construction of dam and power plant, but once those are built, the ongoing costs are relatively low compared to other form of power generation. And now I'm gonna explain about the two environmental impact of hydroelectric development. First one is habitat loss and alteration. The construction of dam and reservoirs can lead to the loss and alteration of nature habits, which can have significant impact on wildlife ecosystem. The Bakun hydroelectric power plant, for example, result in the flooding of over 700 square kilometers of forest, displacing many species of plants and animals. Next one is maintenance missions. Hydroelectric power plant can generate significant amount of maintenance, which is potent greenhouse gas. This is because organic matters in the reserves can decompose and release methane into the atmosphere. The Bakun hydroelectric power plant has been shown to generate significant amount of methane, which contribute to global warming. So, in conclusion, while hydroelectric power plants have the potential to provide reliable and low-cost electricity, they can also have a significant environmental impact, including habitat loss and alteration, and the generation of greenhouse gases. It is important to carefully consider those impacts can build and operate the hydroelectric power plant, and to explore way to mitigate those impacts as much as possible. Thank you.
Question 3. By considering the technical aspects below, demonstrate the principle of hydroelectric in electrical generation with respect to generator frequency and voltage control principles, generator synchronization using synchro-check relay, generator operation with speed and voltage regulation, generator speed and voltage regulation with group, generator parallel operation and load sharing. Generator frequency and voltage control principles. In hydroelectric power generation, the generator produces electricity by converting the mechanical energy of the rotating turbine into electrical energy. The generator frequency and voltage control principles are essential to ensure that the electrical produced is stable and of a consistent quality. The generator's frequency control principle is achieved by regulating the speed of turbine to maintain a constant frequency output. The voltage control principle involves adjusting the generator's excitation system to maintain a constant voltage output. Next, generator synchronization using a synchro-check relay. Before connecting the hydroelectric generator to the power grid, it must be synchronized to match the grid's frequency and voltage. This is achieved using a synchro-check relay, which ensures the generator's frequency, phase angle and voltage are in sync with the grid. The synchro-check relay compares the voltage and frequency of the generator with those of the grid, and when they are in sync, the relay allows the generator to connect to the grid. Generator operations with speed and voltage regulation. The hydroelectric generator's speed and voltage regulation is critical to ensure the stability of the power output. The speed regulation is achieved by controlling the movement of water flowing through the turbine, which adjusts the speed of the turbine and hence the generator's rotation speed. Voltage regulation is achieved by adjusting the generator's excitation system, which controls the magnetic field strength, hence the voltage output. Generator speed and voltage regulation with the droop. Droop is a control strategy used in hydroelectric power generation to regulate the generator's speed and voltage output. In droop control, the generator's output is regulated by adjusting the speed or voltage in proportion to the load and generator. For example, as the load on the generator increases, the speed or voltage output will decrease slightly, maintaining a constant frequency output. And the final generator parallel operation at load sharing. Hydroelectric generator can be operated in parallel to increase power output and ensure continuity of power supply. Parallel operation requires load sharing between the generator, which is achieved through a load sharing system. The load sharing system ensures that each generator supplies a proportionate amount of power to the grid based on its capacity and load demand. The load sharing system monitors the frequency and voltage of each generator and adjusts the load sharing accordingly. Thank you.